Welcome to the dialogue session titled Post-Pandemic Society Between Philosophy and Probability. I'm chair of this session, currently Professor of Political Philosophy, Advanced Social and International Studies, Graduate School of Arts and Sciences at the University of Tokyo. From November 22 to 25, 2021, the ANU, Australian National University, and the University of Tokyo dialogue series are held in Tokyo College, co-organized by the ANU. In the dialogue series, leading scholars from the ANU and the University of Tokyo discuss various aspects of post-pandemic society, including social issues highlighted by the pandemic and how we can prepare for possible future crises. Today, actually the final day of the dialogue series, we discuss how we can tackle the possible challenges and future threats of a global pandemic in a fundamental way. This requires philosophical considerations about the relevant evaluation of risk and impact we call stake of the pandemic. Today's two speakers are renowned researchers who specialize in formal theories which come to terms with philosophical and socio-economical questions of this sort by using mathematical formulations or simply modeling. And formal theories play a significant role in evaluating risk, or more precisely probabilities and stake, low or high. So today's two speakers are the best scholars for this issue. Let me introduce the two speakers. The first speaker is Susumu Kato, currently Associate Professor of the Institute of Social Science at the University of Tokyo. Susumu is an expert of social choice theory and economics of various fields. Susumu has numerous publications. He has published many papers in economics bulletin, social choice and welfare, theory and decision, and also philosophical journals such as Utilitas Synthesis and the Journal of Political Philosophy, which include forthcoming papers. And actually, as a political philosopher, I work with him on political philosophy paper arguments. Hopefully, some papers will be published. That's my sincere hope. The second speaker is Alan Hayek. Alan is currently professor of the School of Philosophy at the ANU. Alan is an expert of the philosophical foundations of probability and decision theory, epistemology, the philosophy of science, metaphysics, and so on. So Alan has a wide range of philosophy interests. Alan has also numerous publications, and his paper, What Conditional Probability Could Not Be, won the 2004 American Philosophical Association Article Prize for the best article published in the previous 2 years by a young scholar. Also, the Philosopher's Annual selected his Waging War on Pascal's Wager as one of the 10 best philosophy articles in 2003. Now, let me briefly explain the time schedule of this session. Each speaker gives 10 to 15 minutes talk. Dialogical exchange follows the two talks. That's very simple, right? Okay, so I'm gonna pass on to Susumu for his presentation. So Susumu, please get started.
Okay, so I'm going to share my screen. Okay, so today I am going to talk about an application of the St. Petersburg paradox to the COVID-19 pandemic. So let me start with some observations. The first, under the COVID-19 pandemic, we people face a severe risk of infection, and I think that the key is heterogeneity. Infection can be fatal for vulnerable people, but for the other people, it may not be fatal, especially if they are vaccinated. So the one thing we should care about is the heterogeneity. Also, after the pandemic, we have another issue. There must be a severe trade-off. by the experience of this pandemic, now we know that the pandemic has a dire impact on the society, and it may happen again with a tiny probability. So the question is, how much should we pay or prepare for the preventing the next pandemic? To think about this kind of question, we need analytical tool, and what I'm using is the expected utility theory, which is very common in economics and other social sciences. And I believe it's also common in philosophy. And the basic idea of this theory is that one should maximize the expectation of utility levels. Any theory has some criticisms. And for the expected utility theory, a well-known one is the St. Petersburg paradox. Let me explain this paradox briefly. Suppose that one person is engaging in a gambling game where a fair coin is tossed. And this game is going to be over if the coin lands heads for the first time. And if that is a case toss, then this person gets 2 to the power of k dollars. So this is the basic rule of this game. And so we will have this table. And if the coin lands heads for the first time on the first toss, the person is going to get $2. This happens with probability 1/2. In the case of the second toss, this person gets $4, which is going to happen with probability 1/4. The third toss, $8, 1/8, and so on. As a result, we have this one, this equation. This is the expected value. And as you can see, this is an infinite sum of ones, and clearly this is positive infinity. Here is the paradox. Because this person is willing to pay an enormous amount of participation fee for this game. And this paradox is inspiring for many people, and some scholars try to avoid this paradox, and the idea of risk aversion, which is very popular in social sciences, was introduced. And recently, climate economics has been developed, and there is a result which is called Dismant's theorem. This theorem was proved by Martin Weitzman in 2009. And the basic message of this theorem is that paying an enormous, almost infinite amount of money for avoiding climate change is optimal. And some people think that this is unreasonable, and it became a controversy. And I think that this result is somehow related to the St. Petersburg paradox. And my idea of this presentation is that if the paradox is related to the climate change issues, then it can be applied or related to the COVID issues. So to connect the paradox with the COVID issues, I am introducing the negative version of the paradox. So here I will derive the negative version of the paradox by using a log UTT function. Let's consider a risk-averse person who has a log UTT function. What we have here is a table which is similar to the previous one, this one. Difference is here. Here we have an increasing sequence of payoffs, and here we have a decreasing sequence. It's becoming close to zero, and this is money. But the payoff is going to be the UTT level, which is log of money. Then money is going to transform, then the -2, -4, -8. This is what we get from this. And so as we can see, this is the inverse sequence of the previous one. So the output will be this one, -infinity. So the point is that the risk-averse agent is very scared of a very bad situation that happens with a tiny probability. And I think that we can apply this game to the COVID-19 pandemic. To do so, I want to introduce one more concept, which is very common or popular in the field of distributive justice, prioritarianism. Let's suppose that there are a finite set of people, n people in the society, and each one has a UTT level. So UI is a UTT level of individual I, and G is a transformation function. So G of UI is a kind of an individual moral value. And so the sum is going to be the social moral value, and the prioritarianism suggests that this sum should be maximized. And if we set like this, G is equal to log, we can combine prioritarianism with the previous version of the paradox. So here are practical implications of the St. Petersburg paradox, or its negative version to the COVID pandemic. First, under pandemic, people may care too much about the risk of infection. Second, after the pandemic, a policymaker may put too much cost, too much money for reducing the possibility of the next pandemic happening, even if its marginal reduction is very tiny. Third, many people may be severely sacrificed for a small improvement of a small vulnerable population. These implications could be reasonable, but these could be unreasonable. This is the point of what I'm not sure about. And anyway, if someone doesn't like these implications, mitigating or avoiding the St. Petersburg paradox will offer some escaping routes from the unhappy policy suggestions of the expected utility theory. And finally, I want to mention one more thing. Even if we avoid these implications, we may still have a deep and more serious problem, since there is a more problematic paradox from Pasadena than the St. Petersburg paradox. This is a work by Alan Hayek, and it's my pleasure to hear the Alan's opinion about these things. So thank you.
Thank you.
Thank you, Susumu. Yeah, so really excellent and very easy to follow the introduction of St. Petersburg paradox. So and also prioritarianism. Alan, could you give us some response? Well, kind of response paper, right? So you prepare. So could you give a response to Susumu's paper in your presentation? Okay.
Yep. So,
yeah.
Arigato gozaimashita. Kono ibento ni sanka dekite koe desu. That's the end of my Japanese, and you'll be glad to hear I'll be speaking in English from now on, because I speak that rather better. Look, thanks so much, by the way. I just want to say how pleased I am to be part of this event, and I hope this will be the beginning of an ongoing dialogue between us. And thank you also to Susumu for that very nice presentation. Just a little bit about me first. I've long been interested in extreme events, and by that I mean high stakes, low probability events. And the current pandemic is an all too vivid example. The stakes are enormous. For most of us, it's the most consequential event of our lifetime. I mean, just to think about it, about 5 million people have died. Many more have suffered long-term health problems. The social and economic impacts have been catastrophic. Yet antecedently, it was improbable that the pandemic would occur roughly when it has, on the scale that it has. Well, how should we make decisions when extreme events are in the picture? And the classic theory of rational decision-making under uncertainty is expected utility theory, and I'm glad that Susumu introduced us to that. And just to recap, the key point is that expected utility of a gamble is the weighted average of its possible payoffs, the weights being their probabilities, okay? As such, expected utility is the sum of products of utilities and probabilities. And on the handout, you see I've highlighted, I've italicized these key words, and I will return to each of them. Expected utility theory says that you should maximize this quantity. I've also italicized maximize. I will return to that. Okay, today, I'm very glad Susumu's already loaded up for us the St. Petersburg game, because that will also be my point of departure. And I will look at some lessons that we can learn from the St. Petersburg game, and they will, I think, give us insights into how to think about prospects of pandemics and how to respond to them. We are, thank you, yes, you're scrolling down nicely. That's just a quick reminder of what Susumu told us. This is the schedule of payoffs for the St. Petersburg game. So I can fast forward down to where it says decision theory apparently tells you, there it is, thank you, that you should be prepared to pay any finite amount to play this game once. And this seems absurd, and I think people would often say, I don't even want to pay $20 to play this game. And we thus have the St. Petersburg paradox. And this is, as Susumu said, this is one of the most famous problems for expected utility theory. Well, if we truncate the St. Petersburg game, it becomes more realistic, but it may still seem problematic. For example, if the coin toss does not land heads by the 30th trial, we end the game. Expected utility theory apparently says that you should pay $30, and that still seems too much. Remember, I just said that even $20 for the full St. Petersburg game is perhaps too much. This game is not as good. You wouldn't want to pay $30 for it. All right. Now, Susumu spoke about a game that involves escalating negative utilities and an expected utility of negative infinity. And that too could be truncated and made more realistic. And now we'll get closer to the pandemic situation. All right. We could imagine ourselves at the start of an outbreak of a new virus, and we're uncertain how serious it will be. And we might model the prospect as the following pandemic gamble. All right, and there it is before us. Great. Now, let's suppose, say with probability half, there'll be a total of 2 deaths. The total number of deaths will be 2. Probability quarter, 4 deaths. Probability 8 deaths. All right, so far, pandemic would be an overstatement. You know, this is a very minor, very localized disease. But watch what's coming. It gets worse. The probabilities get smaller, but the total number of deaths escalate exponentially, and that should be familiar from the St. Petersburg game. And in general, the probability is 1 on 2 to the n, total number of deaths 2 to the n. All right? Now that should look familiar. If this pattern continued forever, the expected number of deaths would be infinite. Very much like Susumu just said, remember it's 1 plus 1 plus 1 forever. Now, of course, there are only finitely many people. There's just under 8 billion people in the world. So let's truncate the pattern. Let's say at n equals 30. Let's say corresponding to roughly 1 billion people dying. That's roughly 2 to the power of 30. Now, this is rather like the negative St. Petersburg game, in which we replace 2 to the n with minus 2 to the n. You have to pay an amount that exponentially escalates according to how long it takes for the coin to first land heads. And the expected value is minus infinity, so the game seems infinitely bad. You should pay any finite amount to avoid playing this game, but that seems too much. We have a paradox. Well, there are so many solutions to the St. Petersburg game and to the negative St. Petersburg game and the paradox that they generate. And this could be somewhat overwhelming. You know, solutions come from various directions and various times in history. And I want to try to just organize this big literature very quickly for you. So I will offer a taxonomy of possible responses to the original St. Petersburg game and the negative St. Petersburg game. And at the end, I will draw some morals for the corresponding pandemic gamble. Now, there are 4 moving parts, as we say, to expected utility theory. And remember, I italicized them, and here they are again. The probabilities, the utilities, the combination rule, sum the products, and the requirement to maximize. Accordingly, there are 4 ways to modify expected utility theory. Modify the probabilities, modify the utilities, modify the combination rule, or modify the requirement to maximize. Or one can keep the theory as it is and find a way to accept its verdicts. And that will be my suggestion at the end. And here we just quickly go through these key ways of responding to the St. Petersburg game. And in each case, I will first discuss what I call a sledgehammer approach, where we somehow radically revise expected utility theory. We smash it, all right? And then right after that, there'll be a more nuanced reply where we tweak it, we modify it, but more subtly. Now, I will argue very quickly against the sledgehammers, but also there'll be problems with the more nuanced replies. They will face a kind of revenge problem where there'll be an escalating St. Petersburg game, you know, even bigger game, call it Super St. Petersburg, that will create the original problem. All right, so now just quickly going through some of these replies, starting with modify the probabilities. For example, Nick Smith, in an important article in Mind, as I would put it, slightly humorously, brings out a sledgehammer. Namely, he says in any decision problem, sufficiently small probabilities may be ignored. Once probabilities fall below some threshold, depending on the problem, they may be treated as zero. Okay, so it's as if those options just don't exist. Okay, and Buffon and Cournot had a similar idea. Sufficiently improbable events will not happen, is the claim. Well, if they will not happen, we can disregard them. We can just say that they're not there. Now, Lara Bushak, in an important book and in other work, she offers a new kind of decision theory, and she allows us to do something gentler, modifying the probabilities less radically. She replaces probabilities with a risk function, let's call it R of P, of them. Now, just quickly in response to these, let me say for a start, for the sledgehammer, I have the following concern, and we could talk about this more in our discussion session. One would think that optimal decision-making should be sensitive to all the relevant information, even if some of its relevance is tiny. But actually, on the contrary, in the very games we're talking about, these low probability events are associated with the highest stakes, okay? And so, and that shows up when you multiply them, their contribution to the expected utility is still the same. Okay, so I don't want to ignore them. Every one in that infinite series counts equally for me. Now, next, just a little bit on Bushak too. She has this risk function R of P, and of course that will rein in St. Petersburg-like games for various agents, but not all agents. For example, some agents could have the wrong shaped risk function. It doesn't grow in the right way to suppress the St. Petersburg game. And also there'll be problems about super St. Petersburg games that escalate still faster. Now, moving on, modify the utilities. First, the sledgehammer. Utilities are bounded, you might say. And this is a very popular response, especially among economists, to the St. Petersburg game. And Arrow, Nobel Prize winner, Hardin, and many others have advocated this response. And, well, just as a very quick reply to this response, I say, well, look, we allow unboundedness elsewhere in our theorizing. For example, think of length, think of volume. In the mathematics of length and volume, we allow them to be unbounded, as big as you like. Think of, say, space-time curvature in general relativity. It can be infinite, certainly unbounded. Anyway, so I do worry about just placing a bound here for utilities. Now, less radical would be to apply a function to the utilities that reins them in less abruptly, diminishing marginal utility. And again, I'm grateful to Susumu that he introduced the log function, and that's what Bernoulli, the great mathematician, did to the St. Petersburg game. He took the logs of the dollar amounts and he got a finite expected utility. But very interestingly, this was Susumu's main contribution, I think, was to show how this same log function yields a negative St. Petersburg game with negative infinity as the expected utility. So the problem arises there. Very interesting. Next, modify the combination rule. Okay, now sledgehammer, you could completely reject expected utility theory. You should say maybe maxi-min, as they call it, is the correct decision rule. Well, again, big discussion to be had, but no, I think that it gives implausible results. It fixates on worst case scenarios. Less radical is so-called weighted linear utility theory, and Chu, and also two students of mine, Chris Bottomley, Tim Williamson, have been doing very nice work using weighted linear utility theory, and it has various nice properties. There's still a worry that there could be super St. Petersburg games that will make trouble even for these more subtle theories. Okay, then we're up to 4, don't maximize. All right, sledgehammer, minimize expected utility. All right, well that sounds crazy. That's almost a joke, or is it? Because now just think about, again, the St. Petersburg game. Suppose that there's an entry fee of, let's say, $1 million to play the St. Petersburg game. You can either pay the $1 million and play the game or not, just status quo. Now, according to expected utility theory, you should pay the $1 million. And according to expected utility, status quo, doing nothing, minimizes expected utility given those options. And yet that's what common sense says. You should not pay the $1 million. Okay? So in that sense, you are minimizing expected utility. Well, less radical would be, and this is a somewhat plausible alternative, let's call it satisficing, and Sloat and others are associated with this. Perhaps you are permitted not to play the St. Petersburg game at a given price, and the status quo, while not your best option, is good enough. And so it's permissible for you to choose that. And again, lots to be said about this, but just quickly a problem. One might say, well, why settle for less than the best when you can have the best? And that seems even more pressing in moral situations, especially, for example, when you're choosing on behalf of others. Okay, and now, thank you, we will move down. And finally, my preferred solution is to try to support expected utility theory. It's correct after all. The St. Petersburg game can be regarded as the limit of a sequence of truncated St. Petersburg games with successively higher truncation points. For example, the game is called off if heads is not reached by the 30th toss. Okay, remember we discussed that? That has a value of 30 in expected utility. Truncated the 31st toss has a value of 31. Call off the game by the 32nd toss, that has a value of 32, and so on, ... forever. Now, if we accept so-called dominance reasoning, these successive truncations can guide our assessment of the St. Petersburg game's value. It's worth more than 30, right? Because it's identical to the 30 game, but then it has some prizes beyond that. It's worth more than 31, it's worth more than 32, ... It's worth more than every finite value, and that's infinite. Now, again, with more to be said about that, I had to give a very quick version of the argument, but you get the idea. So maybe that infinite verdict is not so crazy after all. And then finally, and then my time is up, but thank you for listening. The point of all of this talk of St. Petersburg was to bring it home to the pandemic, and I'll do that via the pandemic gamble. And think about how some of these approaches will look when applied to the pandemic gamble and then to prospects of pandemics in the real world. All right, let's just start with satisficing. I talked about that towards the end. Now, satisficing may be fine when you frame decision problems as being the status quo versus some prospects of gains beyond that. It seems far less plausible that you're permitted to satisfice and choose the negative St. Petersburg game over the status quo. And that seems like the better analog for choosing whether to prevent a future pandemic, 0 lives lost for sure, or not to prevent it, 2 lives lost with probability half, etc. Right? That had to go quickly, but you get the general idea, I hope. Now, also, I don't want to treat a tiny probability of a new kind of extreme pandemic as if it is 0. Then we'll make no effort to prevent or prepare for it, no matter how bad it would be. Now, to be sure, Smith, for example, is not saying you can treat the pandemic as having probability 0, especially given the finite gamble that's involved. But it's just to raise a flag, be careful about zeroing things out, because you won't pay attention, in some cases, to the most severe consequences. And then the more nuanced approaches, like diminishing marginal utility, well, I think diminishing marginal utility is less plausible in population ethics than it is in decision theory. We certainly should not take the logarithm of the number of lives as a measure of how bad various outcomes are. At a first pass, the utility should be linear, a straight line in the number of deaths. Each person is equally valuable. Each successive death counts equally. Well, so you might think, but here's the sort of thought I want to leave you with. I actually think that the utility grows faster than linearly. Each successive death should count for more. Now, what am I saying? Look, to see this, imagine a shockingly catastrophic pandemic that has killed almost every human. We're down to the last 2 people in our current population. We're down to the last 2 people, the last man and woman. And there's a good sense in which they are far more precious than 2 people are nowadays. Because think about it, we're imagining that the human race is right on the edge of extinction. We are on the brink. If either this man or this woman dies, that's it. All right, now suppose we're down to the last 4 people. Well, that's very nearly as bad. Or suppose we're down to the last 100 people. That's not quite as bad, but nearly. And so on. And now return to our current situation. Each death incrementally gets us closer to the nightmare scenario that I've been imagining. The value of each remaining life increases slightly with each death, and more so the closer we come to extinction. Well, when I shifted attention from the original St. Petersburg game to the truncated St. Petersburg game, the full force of the original paradox was diminished somewhat. Remember, infinity became 30, for example, but it was not completely lost. Here, the thought is the opposite. It's because our population is finite that successive losses of life count for more and more. And given what we value, we might say that the disutility of the loss of the final lives, and hence of the extinction of the human race, is infinite. Okay, thanks very much.
Thank you. Thanks a lot. Yeah, as a just participant, I really enjoyed your talk. So, so anyway, before the dialogical exchange, can I have a clarification question about the Alan's talk? Is that all right?
Yes, please.
Yeah. So when I refer to the utility, that is the utility growing faster than linearly, in accordance with the increasing number of deaths, what do you mean by the utility? That sounds like, utility of the collective kind of stuff. So like, human beings on the planet.
Yeah.
But that is not so, that is not so equivalent to the, aggregated kind of stuff. So aggregated utility among individuals. So, so it's a bit for me, confusing to say, the utilities are, utility can be treated in the same way, even when we talk about utilities of the collective entities and utilities, aggregate utilities among individuals. Maybe I'm wrong. So could you explain the point?
It's a good thing to clarify. And I did assume rather hastily that we could translate from the decision theoretic framework, which is usually intended for individual agents, rational agents, to now the case of, let's call it population ethics.
Right.
And I guess a bridge is so-called utilitarianism, okay, where you imagine in some sense summing the well-beings of many, many people, and we measure them somehow with utilities and we aggregate. But we don't necessarily need specifically utilitarianism, but somehow the thought is that we measure goodness, or in this case, badness of a scenario using utilities, and that's familiar from decision theory. And we then use the number of deaths as a proxy for badness, basically. And in fact, I was suggesting that badness does not just go linearly, but even steeper than linearly when it comes to number of deaths. So, and there is a big literature on translating between the two. By the way, Susumu, I guess, did a little bit of that too. He mentioned prioritarianism as a sort of, measuring the well-being of a society. And that involved a kind of translation between the individual decision theoretic framework and that for social choice and for population ethics.
Thank you very much. Yeah. So, Susumu, I think you have lots of questions and responses to Alan's talk. So please get started, Susumu. Any question or any comment? Yeah.
I really like the framing of the pandemic game of by Alan. That's very fascinating to me. It's I started from climate economics when I saw the St. Petersburg products. So I couldn't get rid of the utility function component, but the Alan's way is more direct. It's very nice and beautiful, and so what also related to the Akira's question, I think that we are thinking the same thing. I mean, so badness is basically going to be a minus of goodness.
Mm-hmm.
So marginal. So I'm thinking about the economics. Marginal cost is usually assumed to be increasing, and it's going to be the diminishing marginal utility, because we are taking the minus of that, the opposite value of that one. So yeah.
And logarithm.
Yeah.
I do have something to say, but I don't want to interrupt you.
Yeah. Oh, please.
Yes, please. Yeah. This is dialogical. So yeah. Yes.
Yeah, and it was very nice that you took the log function. The logarithm of the dollars was the utilities. And by the way, that has a nice historical antecedent, as I said, in Bernoulli, who both introduced the St. Petersburg paradox and in a sense solved it and introduced this important notion in economics of diminishing marginal utility. But there's just, I guess, one curious feature about Susumu's game, which I'll point out and then maybe explain slightly. So notice that in his game, every payoff was positive. You will only win money. You don't have to pay anybody. You will finish off better having played the game for money. And yet, lots of the utilities were negative, right? And so at first you might be puzzled, well, hang on, how could it be a bad thing for me to receive money? I like receiving money. I would prefer to get more. Maybe I'm a bit sorry that I don't get a bigger amount, but I'm still glad in some sense to get the small amount. So how could that be a bad thing? But one shouldn't just think of utility in the way maybe Bentham or one of the utilitarians would, that it's just a measure of hedons or happiness or goodness or something. It's a sort of representation of your preferences, all right? And given your preferences, this utility curve will capture, right, what you prefer over what, by how much, and so on. So that's just to explain a little feature of his game. I will mention the so-called certainty equivalent, namely, how much would you pay to get this game? What would be the thing you would pay for sure that you think has the same value as this gamble? And I gather, Susumu, for your game, it's 0. The certainty equivalent of your game is 0. And that might seem a little odd because you're guaranteed to make some money.
Mhm, mhm.
But that's, again, the puzzling feature of the infinite expected
Right.
utility. That's what happens when you keep on adding these 1 + 1 + 1s forever.
Yeah, I haven't thought about that. Yeah, but yeah. It's a very tricky and interesting. Right.
Hmm.
Yeah.
Right.
Yeah.
So, Susumu, do you have any other question on other parts or the same
yeah,
point?
I have a kind of I don't know if this is a big question or not. And so when I heard Alan's response, I was thinking about the the negative version of Pascal's wager.
Yeah.
Like when I was a kid, the prophecy of the Nostradamus was very popular in
too.
Japan, and it's like the world is going to end in 1999, and some weird people were saying that donate money to me, and then you will survive, and so you know in the case of pandemic, preparing for an extreme case is makes sense, but how can we handle the such an the weird case?
Yeah. Good. Look, I'm so glad you brought up Pascal's wager. I would have liked to in a longer version of this, and I've written a lot. I've thought a great deal about Pascal's wager in my philosophical career, and there is something Pascal wager-like about the pandemic. Of course, as you say, it's a negative Pascal's wager. To put it in maybe more Pascalian terms, it would be like damnation. Okay, like hell has minus infinity utility, and now you want to avoid hell, and a Pascalian calculation seems to say that whatever you do has negative infinity as its expected utility, and that's pretty scary. Actually, by the way, it just occurs to me it's worth saying this. So far, we've been pretending that these games are being played, these gambles are happening. But notice that you get the same paradox, even if there's just some probability of playing the game. So I don't think I will ever play the St. Petersburg game, right? I'd be amazed if someone offered me the St. Petersburg game for real. But having any probability whatsoever for the prospect of the St. Petersburg game is just as paradoxical. If I give probability 1 in a million or 1 in a billion or 1 in a Googleplex to playing the St. Petersburg game, I still have infinite expected utility right now because I multiply infinity by a millionth or a billionth or a Googleplex or whatever. That's positive. So something positive times infinity, still infinity. Wow, I've got the problem right here. Okay, but now bringing this home to what you did, Susumu, it seems the same thing goes for the pandemics. So even if I think that this pandemic that we've been talking about is very unlikely, okay, still, it seems the full force of the paradox hits us. You multiply some small probability by something with negative infinity as its utility, expected utility, and the answer you get is negative infinity again. And so we can't be sort of smug and say, well, haha, these are all just philosophers' fantasies and so on. If you just give any credence at all to the prospect, the paradox hits you too. And now, admittedly, the infinite version of the pandemic, maybe that is pretty far-fetched. There are only so many people. But still, it's a bit sobering to think that you don't even need to be playing these games for them to have their menacing consequences.
That's right. Yeah. Maybe I should make the discussion a little bit more down to earth, but I'm not sure whether I can do that. But
I'm not sure I
yeah,
can.
yeah. But actually, what Alan now is saying is related to kind of real situation or real possibility, more possible, right? Rather than just doing St. Petersburg game.
Yeah.
So I think that's an indication of the this kind of problem occurring possibly in the near future. And that's really important to see, and to take seriously the impact and the consideration of St. Petersburg paradox. So related to this kind of my interest and also maybe people's interest in St. Petersburg paradox, which is actually, close to, the real situation, and can be interpreted as a closer situation, closer case to real situation. You actually frequently refer to, super St. Petersburg paradox, right?
Yeah.
That's, I think, logically, what I suppose, problem suddenly with some sledgehammers ways of dealing with the problem. So like Buchak's way, risk function kind of stuff, and also weighted function is introduced, like prioritarianism. Still, we face such a kind of super St. Petersburg paradox, but that's really extreme case. Sounds like actually prioritarianism faces a similar kind of objection, so-called super repugnant conclusion. That is a really large number of populations outweigh the evaluation of very small but highly regarded lives. That could be in terms of value. I think so. There is a similar kind of structure, but still, that is really exceptional. And actually, we can hardly imagine the case obtains, especially in the case of super repugnant conclusion and also super St. Petersburg paradox. That is what I misconstrue your argument or your discussion. But could you say something about this kind of impression or my argument? Yeah.
Excellent. I've got at every stage I have something to say. A little bit on super St. Petersburg, just to make sure everyone's clear on what
please.
Getting at there. So remember, we were talking about, well, there was the St. Petersburg game, and if you took the logarithms of the dollar amounts, then there was no big problem, it seemed, because the series converged. But now, instead of taking the payoffs growing at 2 to the power of n, make them 2 to the power of 2 to the n, okay? So super exponentiate. Now take the logarithm, okay? And then you get back to where we were. Well, actually, I assume you used e, so maybe I should have used e. E to the power of 2 to the n, take the natural logarithm, and then that erases the e, and you're back to the original game, which was 2 to the n. So the full force of the original game hits you even after you've taken your logarithms, all right? So that was the point about super St. Petersburg. I think we could sort of order, and actually, Akira, your point began with trying to consider what, slightly more realistic versions of this. So I could order our prospects as follows: very unrealistic, super St. Petersburg, crazy unrealistic.
Right.
Still pretty unrealistic, but slightly more realistic, St. Petersburg, but I'm not pretending it's real. Now, certainly more realistic is a truncated version. And actually, if you truncate low enough, you could literally play the St. Petersburg game. It wouldn't be that hard to play the St. Petersburg game truncated at 10, for example. We could do that right now. But remember, I said that some of the worries about St. Petersburg still apply even for the truncations, all right? Not as extreme, it's not infinite, but it's still maybe troubling enough. You know, maybe, for example, paying $30 for the truncated at 30 game. And by the way, even if you think that expected utility theory overvalues these truncated games, still my argument at the very end, I think, goes through. As long as their values increase without bound, the original St. Petersburg game is better than all of them, and so it must be infinite. And that's still the very disturbing conclusion. And the final thing I wanted to say was about prioritarianism. And it occurred to me that I was assuming maybe a kind of prioritarianism on the value of lives, and I was putting more value on the last lives. You know, I said, when you're down to the last 2 people in the human race, you have to put tremendous value on those 2 lives, all right? The last 4 people, well, that's getting close. You have to put a lot of value, and more value than on current lives when you've got nearly 8 billion people still left. So I just wanted to make the final comment that prioritarianism also allows me to put extra weight on certain people, I suppose, depending on where they are in history and how close we are to extinction.
Right.
Yeah, but thank you for the question.
Yeah, thank you very much. Susumu, would you like to have some, comments or remarks or whatever?
Yeah, about the prioritarianism, or about the in the theory of distributive justice, redistribution is going to be a big issue, and so I'm thinking about the situation where there is only one guy is facing the negative St. Petersburg paradox, and the other people are normal, like 1 million people or billion people are doing the standard or usual game, and so this one guy with the negative St. Petersburg paradox game is his utility is very low, expected utility is very low because he's facing the negative version. So I think that the policymaker or prioritarianism is going to suggest that enormous amount of money should be given to the is that
yes, I see. Yeah.
It's not reasonable. So this is a kind of a thing which is which should be considered by a prioritarian, I think. Yeah.
Yes, I'm reminded of Nozick spoke of the utility monster.
Yeah.
I think that was a problem for utilitarianism, and so now, yes, we imagine this agent, your agent in your game, who's like this utility sink, and you just have to keep on rewarding this agent. Yeah.
Right. Okay, so now I think the time is up, but if you have some comments or have some want to share some ideas, please go ahead. If not, it's time to close, so I have to wrap up.
Yeah. Just very quickly, I'm glad
please.
You mentioned the Weizmann, and I guess I gave some sympathetic points supporting this rather radical conclusion of Weizmann's, that you may have to take seriously these very low probability prospects. He was talking, I think, more about climate change, as you said, and it was nice that you made the analogy to the pandemic, because it seems like a very close analogy, and the points will go through rather similarly. Yeah.
Susumu, could you give some comments?
Oh yeah, what I want to say is that I really enjoyed the conversation
too.
and this session.
Yeah,
It was excellent. Yes, thank
yeah,
you.
very excellent. Yeah, yeah.
Yeah.
So it's time to, unfortunately, it's time to close, but I think we should continue to have a discussion like this. So I
Yes.
sincerely hope, Alan is invited to the University of Tokyo in an on-site manner. That's my hope.
It would be such a pleasure. Yes.
After this, crazy pandemic is over.
Yeah.
So
Yes.
yes, that's I think pretty likely,
Yeah.
not uncertain.
Yeah,
I hope so.
Yes, that is a near certainty. That's right.
Yes, certainly. Yes, certainly. Yes, yeah. So yeah. So thank you very much,
It was lovely.
to the audiences for auditing. So thank you very much for the audiences to audit this session, and many thanks must go to Alan and Susumu for excellent talks. Thank you very much, and yeah, that's it. Thanks.
Lovely. Thanks to you all. Great. Sayonara.
Sayonara.